Hi everybody, it's Mrs. Baxter, and today we are going to be moving on from adding and subtracting radicals to multiplying radicals, or multiplying what we call square roots. Now, multiplying is a little bit different than adding and subtracting. In adding and subtracting, remember, we're looking for the same radicand or the same number underneath the radical sign in order to combine those like terms. Well, that is a little bit different when it comes to multiplying. With multiplying, here's the rule that we're going to follow. Okay, when we multiply, we're going to make sure that we multiply coefficients, which is the same thing as the number in front of the radical. Okay, so when I'm looking at the number in front of the radical, I'm looking at this number right here, the 7. It's in front of the radical sign. And I'm looking at 5, which is right in front of the radical sign, okay? When you then multiply those together, you're going to then move on to multiplying the radicands, which is the number that is underneath the radical sign, okay? So when I'm looking at that, I'm actually looking at the 6 here and the 15. Okay, those two I will multiply together. So let's try example number 1. Oh, and before I do that, always make sure your radicals are simplified either before or after you multiply. So you can simplify, it just has to be done before or after. I recommend when the radicals are small enough like they are in our first few examples, that you do it after. Okay, when you start getting bigger radicals, then you're going to definitely want to do them beforehand. Otherwise, you'll get like numbers in the thousands, and that's just not fun to split out into a tree. All right, so let's look at this first example. I'm going to look at multiplying 7 root 6 times 5 root 15. And when I do that, I'm going to make sure I'm doing my outsides first. Oops, outsides first. Okay, 7 times 5 is 35. And then I'm going to be looking at multiplying underneath the radicand, 6 times 15, which is 90. Okay, and this is going to be your answer right here. Okay, so essentially what we're doing is we're doing 7 times 5, square root 6 times 15. Okay, so if you need a little explanation, go ahead and break that down a little bit. All right, looking at example number 2. Okay, you guys might be looking at this saying, oh, what do I do with this? Well, if you remember, we have an exponent here, it's raised to the second power, which just tells us that we're multiplying 4 root 5 by itself twice. Okay, so let's go ahead and do that. We're going to rewrite this equation to 4 root 5 times 4 root 5. Okay, and we're going to look at multiplying our outsides. 4 times 4, let's see, and then we're going to multiply our insides. 5 times 5, okay, and if I simplify that, I'm down to 16 root 25, okay. When we're looking at root 25, I hope you noticed it's the same thing as 5 times 5. The square root of 25 is 5. So we have this very nice simple number. 16 times 5 goes on the outside now. Because we have nothing left over, there's no radical sign. It's just now a whole number, and this is equal to 80. We don't need to simplify it. That is as simple as it gets. All right, I like that problem. Okay, let's look at a word problem here. It says, find the area of a rectangle whose length is 4 root 32 and whose width is 2 root 54. All right, well, just to review a little bit with word problems, we're looking for keywords here. And some of the keywords I'm seeing are, let's see, area of a rectangle. Okay, I'm seeing, length is 4 root 32, width is 2 root 54, okay? If you recall, the area, the area of a rectangle is length times width. And we have our length here and we have our width here. So it would make sense that we are going to multiply those two radicals together. Now, when I write down 4 root 32, I'm seeing my 32, it's pretty big. We can go ahead and break that down. I recommend it because it's going to be quite a bit easier to multiply these once we simplify. So as small as you can here, it's kind of nice because this just breaks out to 4 and 4. We can stop right there so that I know that I'm taking my 4 outside and I'm going to have 4 times 4 square root. I'm left with 2 left over, okay? So I'm going to write this off to the side here. I'm going to go start a new problem here. We've got 16 root 2, okay? And then we're going to multiply it by something, because we're going to multiply it by 2 root 54. Again, I want to split this out. 4 is an even number, so I'm going to start off by 2. This works out to a nice 27, which is 3 times 9, and then 3 times 3. After a while, you start seeing these patterns. Make note of those patterns. So this turns into what? 2 on the outside times 3 on the outside, right? We have this and 3. And then I've got 2 on the inside and 3 on the inside. So when I multiply them out, I get 6 root 6. All right, now we're going to multiply outsides together. So 16 times 6 is 96. And 2 times 6 is 12. Okay, but then I'm looking at my 12 and I know I can break that down again. 2, 6, 2, and 2 times 3. Actually, let me do what I said here. 2 times 3. There we go. And if I break it down, now I'm going, now I've got to go, okay, 96 times 2, right? I'm going to multiply that outside, and then I'm left with 3 left over on the inside. So my new final answer is 196 times 2 is 192 square root 3 left over. This is our final answer here. Now, when you have a word problem, make sure you double check. Does this have units in it? Well, this one doesn't specifically tell us it's in square inches or square feet or whatever. So this is your final answer. You're done. So we're good. Cool. All right. Next step. I'm trusting you guys. I think you guys can get this. We haven't done this skill in a little while, so let me review. But we're now going to multiply a monomial by a polynomial. And what I mean by that is we're going to take one term and multiply it by our parentheses, and there's going to be 2 terms or 3 terms on the insides of that parentheses, okay? And we're going to go back to distribution. Distribution never goes away. You got to keep distributing, and you're going to distribute to everything on the inside of the parentheses. Again, with multiplying, you're going to multiply your coefficients, or the number in front of the radical, with the number in front of the radical, and the radicands, which is only the insides underneath the radical, okay? You cannot mix outsides and insides. Your outsides multiply outsides, insides, insides, and then you can simplify from there. Okay. In this instance, again, you can simplify either before or after you multiply. If the numbers are smaller enough, then I wouldn't worry about it. But if they start getting bigger, then simplify before you start going. All right, let's look at this example right here. 2 root 3 times root 3 minus root 5. Now, this is an interesting problem because I'm looking at it going, oh, wait, I don't have anything in front of my radicand. So what can you guys assume about the fact that there's no number in front of the radical sign? I mean, there's nothing here, right? There's nothing here. There's nothing here. Oh, but there is, Mrs. Baxter. What's my favorite number, y'all? Yes, you're right. It's a number 1. So number 1, you can assume, is in front of a radical where it doesn't have a number, okay? So we can pretend there's a number 1 here, 1 here, 1 here. I don't want you to write those ones in, okay? Because it just gets a little bit more confusing. So since we have no numbers in the front, let's just go ahead and multiply the numbers on the inside. All right, so I have 2 times 3. Remember, we are going to distribute this term to both of the terms. So do one at a time, always work from left to right. I have in this situation root 2 times root 3. You can go ahead and put them under the same house, if you will. And then once we do that, we're going to do root 2 times negative root 5. So I'm going to go like this, negative, and then I've got square root 2 times 5. All right, let's simplify that. I now have root 6 minus root 10. And actually, y'all, this is your final answer because root 6 and root 10, we cannot simplify that anymore. Remember our add. Remember, add and subtract. Like terms only. Okay? So if they are not like terms where the radicand is not the same, you cannot combine them. Okay, you're done. Cool. All right, let's look at something just a teensy bit harder with example number 5. With example number 5, we've got a little bit of a combination thing going here. All right, I'm looking at this and I'm thinking, you know, I can't simplify anything right now. I'm just going to go ahead and straight up multiply. I'm going to distribute. So this is my outside term here, right? I'm going to take this monomial and I'm going to multiply it to both this number here and then the second number. But let's do this first one first. Okay, so if I multiply, I'm going to do my outsides. So 10 times 6 square root 3 times 5. Okay, and when I multiply that out together, I get 60 root 15. Okay, that's my first term. Then I'm going to multiply my first term with my second term, and you guys are going to notice, oh, there's no number on the outside right here. Let me see here. How do I show you this? There's no number right here. See that? So we can assume that's a 1. Okay, I'm still going to multiply my outsides and my outsides. So I'm going to go 10 times 1, my imaginary number here. Let me make sure I just do like this, okay? And I'm going to get plus, I'm going to just go 10 times 1 square root, and then now I'm going to do my insides, 3 times 15. And if I simplify that, I'm going to get plus 10 root 45. Okay, that's looking pretty good. I'm looking at my root 15 and root 45 to see if I can combine like terms. Well, I can't, but I'm looking at root 45 and wondering, can I simplify that even more? Well, guess what? We can. So let's break this down. Because it ends in the number 5, I'm always going to divide by 5. And 5 times 9 is 45. Let's break this down a little bit more. Look at that. I've got a lovely 3 that can come out. So if I take 3 times 10, this is simplified to 30 root 5. And then I'm just going to bring this down, 6 root 15. I already know I can't break 15 down anymore. So this is my final answer because my root 15 and root 5 are not like terms, right? So there you go. That's all there is to it. Go ahead and grab the homework. If there's something in here you're not quite sure of, or you get to a problem in the homework that you're not quite sure of, please ask a neighbor, please ask a friend. You should not be staring at a problem for longer than a minute, maximum 2 minutes, without asking for help. Okay, and if you have gotten maybe halfway through your homework sheet, there is an answer key for you to check with the instructor. So go ahead and double check your work before you get too far to make sure that you're answering them correctly. All right. See how far you can get. If you have questions, I will be back in the class tomorrow and we can review, or I should say there's no school tomorrow. So make sure on Wednesday when I see you, we will review this. If you have any further questions, please let me know. All right, hope you have a great day. Thanks.